Food waste is a major global problem that has far-reaching implications related to energy, water and land use, greenhouse gas emissions and economic losses. The origins of food waste can be attributed, at least in part, to changing perceptions of the societal value of food, and now losses of edible food materials are observed across the entire farm-to-fork spectrum, from agriculture to food processing, distribution, and consumption. Although most waste occurs at consumer-facing businesses and households, at these stages the waste materials are relatively heterogeneous and dispersed, and thus difficult to divert to productive use. Widely promoted food recovery hierarchies place the highest value on providing excess food for human or animal consumption, but a relatively small fraction of the total waste volume is suitable for these uses. Waste-to-energy conversion methods, including anaerobic digestion, fermentation, transesterification, bioelectrochemical systems, gasification and pyrolysis, and hydrothermal liquefaction, may provide viable alternatives, but their environmental and economic performance must be rigorously evaluated at a system level. The optimal pathway is also dependent on the existing policy and regulatory framework, as well as factors that influence system deployment, such as waste feedstock transport and energy distribution logistics. About 1/3 of the food produced in the world for human consumption gets lost or wasted every year. This quantity is shocking considering that it counts approximately for 1.3 billion tons of food. As it can be easily understood, the problem of food loss and waste is directly connected to hunger and global sustainability in the 21st century. However, the problem is even bigger than it seems, as food loss also accompanies a major squandering of resources such as water, land, energy, labor, and capital. In addition, it is connected to increased and unwanted greenhouse gas emissions that contribute to global warming and climate change. The problem of food loss and food waste is so big that it cannot be solved with mere activities or simple suggestions. It can be eliminated only by facing challenges and providing continuous solutions, at all levels of food production and consumption for all the involved actors and stakeholders. Correcting the policy framework, optimizing agricultural practices, shaping food production, changing consumers' and companies' attitudes, motivating retailers, promoting packaging and process technologies, valorizing waste streams, and other actions should also be taken into account. Subsequently, a guide covering the latest developments in this particular direction is required. Food losses and food waste, FLW, have attracted much attention in the world recently and become a priority in the global and national political agenda, e.g., United Nations Sustainable Development Goals Target 12.3. Better understanding of the availability and quality of global FLW data is important for benchmarking reduction goals, environmental impacts analysis, and informing mitigation measures. In the past few years, there has been more and more literature on FLW quantification. However, these studies still suffer from some gaps, such as data deficiency, low CODA consignment, geography, and food supply chain. In this chapter, the FLW data for each 4 countries and 52 individual years during 1942 and 2014 in 202 publications were examined. The results show that most existing studies are carried out in a few industrialized countries, such as the United Kingdom and United States, and more than half of them only depend on the secondary data, which indicates high uncertainties in the current global FLW database. The available data also show that per capita food waste generated from households rose with the increase of per capita gross domestic product. More consistent, deep, and direct measurement-based studies are urgently needed, especially for emerging countries, to better inform policy making and mitigation strategies on the environmental impacts. Definition of food losses and food waste. Food losses refer to the decrease in edible food mass throughout the part of the supply chain that specifically leads to edible food for human consumption. Food losses take place at production, post-harvest and processing stages in the food supply chain, Parfit et al., 2010. food losses occurring at the end of the food chain, retail and final consumption, or rather called food waste, which relates to retailers and consumers' behavior. Parfit et al. 2010. Food waste or loss is measured only for products that are directed to human consumption, excluding feed and parts of products which are not edible. Per definition, food losses or waste are the masses of food lost or wasted in the part of food chains leading to edible products going to human consumption. Therefore, food that was originally meant to human consumption but which fortuity gets out the human food chain is considered as food loss or waste even if it is then directed to a non-food use feed, bioenergy. This approach distinguishes planned, non-food uses to unplanned, non-food uses, which are hereby accounted under losses. Quantification of food losses and waste. Physical mass of food produced for human consumption and of food lost and wasted throughout the food supply chain have been quantified, using available data, results from the literature on global food waste and SIK's own assumptions. For each commodity group a mass flows model was used to account for food losses and waste in each step of the commodity's FSC. Model equations are provided in Annex 5. The production volumes for all commodities, except for oil crops and pulses, were collected from the FAO Statistical Yearbook 2009, FAO-STAT 2010A. The production volumes for oil crops and pulses were collected from FAO's Food Balance Sheets, FAO-STAT 2010D. Allocation factors have been applied to determine the part of the produce oriented to human consumption and not for animal feed. Conversion factors have been applied to determine the edible mass, Annex 2. Food is, of course, essential for organisms to live, thrive, and propagate, but the relationship between human beings and the food they consume has evolved in many ways over the centuries. The Haudenosaunee Iroquois, Peo-Pli, who widely inhabited our region of New York State before the arrival of European settlers, had a deep spiritual relationship with food. The three sisters of corn, squash, and beans were presented as gifts directly from the Creator and considered essential to sustaining community life. Lewandowski, 1987. In most regions of the globe, food has been assigned great significance in representing cultural, religious, ethnic, and national identity. But today, few people in the developed economies of the world have direct, personal involvement in the enterprise of producing food, and therefore wasting it does not seem particularly arrogant or vulgar. Whereas the Iroquois associated their very existence with the ability to plant and nurture certain staple crops, in modern times we discard half-eaten apples or sandwiches without even a hint of introspection. As the global community begins to seriously consider the implications of human-induced climate change and a rising population expected to exceed 11 billion by the end of the century, United Nations, 2015, it is important to address the problem of food waste and the very real sustainability threat it represents. While much of the developed world tries to decide how to stop wasting so much food and the precious natural resources contained therein, other much larger populations in developing countries suffer from severe food insecurity. But even in the United States, it has been estimated that 1 in 7 people face some food insecurity throughout the year. ReFed, 2016. Such disparities between the haves and have-nots have many political and social justice implications that are beyond the scope of this book. Our objective is to approach this problem from a strictly technical standpoint, and in this context the imbalance between food supply and demand indicates that significant inefficiency exists in the global food system. According to a recently published study, the impacts of food waste on the U.S. economy are staggering, accounting for 21% of fresh water use, 19% of fertilizer use, 18% of cropland, and over 21% of landfill volume, all at an annual cost of $218 billion, more than half of which is borne directly by consumers. ReFed, 2016. To develop a viable societal strategy for addressing the food waste problem, it is instructive to first consider some of the trends responsible for changing attitudes toward the agricultural and food system in the United States and other developed